kinetic molecular theory and effusion versus diffusion. An ideal gas versus a real gas. There are two different types of gases, believe it or not. Ideal gases is a theoretical gas composed of many randomly moving particles. They are not subject to interparticle interactions. So in other words, the IMF, they have no IMFs. We do use PIVNERT or the ideal gas law to solve for this. PV equals nRT when we talk about ideal gases. A real gas is simply the opposite. It does occupy space, and the molecules have interactions, so they will have intermolecular forces. We often talk about the intermolecular forces and use the van der Waals equation to talk about real gases. I am not going to cover van der Waals equation in this unit, so if you want to learn more about that, please seek elsewhere. The kinetic molecular theory, on the microscopic level, we can see why real gases approach the behavior of the ideal gas PV equals nRT. And we did talk about that ideal gas law in a different video. It does help explain those properties. We know that gases are composed of molecules that are continuously moving. They travel in straight lines and change direction only when they actually collide with something else. It's kind of like if you roll a ball, it will only change directions if it collides with something else. The molecules composing the gas are very tiny, and so is the distance between them. The pressure that's exerted by a gas in a container results from the collisions between the gas molecules and those container walls. The gas molecules actually have no attractive or repulsive forces on the container or the wall, so they're just going to continually move and not hit each other unless they have the perfect conditions. Therefore, when they do collide, their collisions are elastic. They do not actually involve a loss of energy. So the average kinetic energy of the gas molecules is proportional to the Kelvin temperature. So if the temperature increases, the particles will start to move a lot faster and have way more collisions. If the temperature is decreased, their collisions will lower and they will have less. So just to remember that gas pressure is exerted by rapidly moving gas molecules, and it does depend directly on the number of molecules hitting a unit area of the wall per unit. So if we change how fast, how often, or how hard the gas hits the side of the container, the pressure is also going to change. You can think about this and use the different gas laws to figure out how it would affect all the other variables. So for example, we are looking at Charles's law. So if the pressure is constant, the volume will increase as temperature increases as well. So here we can see the volume and the temperature. We see the flame underneath. As the temperature starts to increase, the volume will also increase as well because those two are directly related, as Charles's law states. Another example is Boyle's law. Here is our baseline right here. If you decrease the volume, then the pressure increases because pressure and volume are inversely related according to Boyle's law. And finally, Avogadro's. We have our baseline here. We added more molecules to it, so it does increase the volume. Volume and the amount are directly related. So what I'm telling you is that molecules move very rapidly. They have no attractive forces, which means they are constantly flying by each other. They are very far apart. They have big distances between them, and they have a ton of elastic collisions because they don't actually hit each other and stick to them. They never lose their kinetic energy, but if you do increase the temperature, the gas molecules move much faster. And if you decrease the temperature, the gas molecules, it will slow down. Okay? If you have any questions about the kinetic molecular theory, make sure you ask your teacher. Affected by the gases and that kinetic molecular theory. Diffusion is the process by which a gas spreads through a space occupied by another gas. Essentially, it's the mixing of gases. So if someone opens a hand sanitizer at the front of the room, a few minutes later, everyone is going to be able to smell it. Or if the home ec teacher starts making cookies, everyone will smell them. The same thing with the cafeteria. Can you tell how far gas molecules would actually move? You actually can, because the distances traveled are due to the gas's molar mass. You would use that periodic table to find the molar mass. Lighter molecules are going to diffuse faster than heavier molecules, so the lighter molecules move much faster. So if we take a look at this picture, we have hydrogen and oxygen in two separate containers that are blocked off from each other in the initial picture. So once that stopcock is opened, the lighter gases move much faster. So hydrogen is going to initially move much faster into the oxygen one because it is so much lighter. Eventually, after some time, they are both going to even out or balance out, so the hydrogen and the oxygen will be evenly distributed. Effusion is similar but different. Effusion is the process by which a gas escapes from a container into an evacuated chamber through a tiny pinhole. So effusion is through a tiny, tiny hole versus diffusion is just moving everywhere. It's kind of like what happens to a gas when you poke a hole in a tiny balloon. The air slowly evaporates out. So usually only one gas particle can pass through the opening at a time. Okay, and the lighter gases, once again, are going to pass through the open first before the heavier gases do. If you have more questions on diffusion and infusion, check in with your teacher.